Hi guys, in today's video we're going to take a look at balancing equilibrium and yield, the Haber process, looking at the ideal conditions, issues with these, modern manufacturing conditions, an exam style question, and finally a summary.
So first of all, let's discuss the balancing of equilibrium and yield. Well, industrially, the yield of a reaction must be balanced against the economic feasibility. The optimum yield is of course desired. We want to get as much as we can out of our chemical reactions. However, the optimum position of the equilibrium must be considered. Now, to understand this, we're going to put it into the context of the Haber process. The Haber process is a process you may be familiar with. It is a reaction between nitrogen and hydrogen to form ammonia, an incredibly useful chemical. So the optimum conditions for our Haber process are a high pressure and a low temperature. So let's look at why these are the optimum conditions. Well, the reason that a high pressure is preferred is because on the left-hand side over here, you can see we have 4 moles of gas, whereas on the right-hand side, we have only 2. A high pressure, or increasing the pressure, will cause the system to move to the right. We know the system will move to the side with the fewest number of moles, which is the right-hand side, producing more ammonia, more product, and increasing and optimizing our yield. So why is a low temperature favourable? Well, as we can see here, the Ford's reaction is exothermic. The enthalpy of the Ford's reaction is minus 92 kilojoules per mole. So decreasing the temperature will cause the reaction to move in the forwards direction. And that's exactly what we want. By decreasing the temperature, we cause the reaction to move forwards, producing as much ammonia as possible. However, although these conditions will maximise our yield, there are some problems with them. Although increasing the pressure to a high pressure increases the concentration of the gases involved in the reaction and will increase the rate, lots of energy is required to maintain these pressures. And not only is this expensive, but storing gases at such high pressures is potentially unsafe. If an accident were to occur, it could be catastrophic. Well, low temperatures, although favourable to the yield, will decrease the rates of reaction, which is not ideal. So you can see how we must balance the optimum yield against the economic feasibility of our reactions. So now I've had a look at the ideal conditions and the problems with them. Let's have a look at the industrial conditions used in the modern manufacturing of ammonia through the Haber process. The temperature used is around 400 to 500 degrees Celsius. So this is high enough to allow the reaction to occur at a good rate, but also produces a suitable yield.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.